So we continue with integration, and so integration, and the first case is with the partial fractions. Integration and partial fractions. Yes. So we will get back to our findings from the previous work, particularly on partial fractions. Yes, so we assumed a fraction and we followed the sequence of steps for simplifying that partial fraction for integration. So let's say the integral to be found is 1 by x plus 1 into x plus 2, integral sign, differential sign. Yes, so this is what we are looking for. Okay. So the fraction is 1 by x plus 1 into 1 by x plus 2, and it is equal to a by x plus 1 plus b by x plus 2. Okay, this is the general form in case 1 of partial fractions. So we go about solving for integration this time, not the partial fractions. So the partial fraction in this case, as we found out, was 1 by x plus 1 minus 1 by x plus 2. Okay, so this is the function that we integrate now. 1 by x plus 1 minus 1 by x plus 2. Yes, so how we integrate it? Something like this: 1 by x plus 1 minus 1 by x plus 2, differential sign. Yes. So, and from the basics of integration, what we know is that 1 by x is natural log of x. So so here we have 1 by x plus 1, which could very well be natural log of x plus 1 minus, in this case, natural log of x plus 2. Yes, so this is what we have. Okay, plus c, which is the constant of integration, c1 plus c2 capital C. Okay, and the same a similar function, let's say this is a partial fraction, these are just the fundamentals. Okay, these are not the nitty and gritty. So now we get into by parts. Yes, the next method of integration. So integration by parts. So for instance, we have a function in the product from x plus 1 into x plus 2, and we are supposed to find the derivative, the antiderivative, the integral. Okay, so we call this function 1 and we call this function 2, and what we do is we use the formula I is equal to integral is equal to first function into integral of second function minus integral of second function into differential of first. Into differential of first. Differential means derivative times the dy by dx dot dx. So dy by dx for x plus 1 would be 1 and then dx. So we can ignore this one and we can do something like this if I'm not wrong. All right, so let's just do it properly. D by dx of x plus 1 dx. Okay, dx cancels out and okay, sorry, d by dx of x plus 1 gives us 1. So the integral continues to be x plus 1 into, you see, x dx plus 2 dx, yes, and minus now x dx plus 2 dx, yes, you see. So we continue x plus 1 times x squared by 2. It's basically the formula. So we need to actually look into the fundamentals of integration. For example, the integration of x would be x to the power 1 plus 1 by 1 plus 1, okay, and the integration of 1 by x would be natural log of x plus constant of integration plus constant of integration. Okay, so these are just the basics revised, and now we get back to the problem. Okay, so we have this here outside plus 2x, and integration of a constant is equal to c dot x. Yes, constant can be taken out and 1 is integrated to x minus, once again here, x squared by 2 plus 2 dot x, or simply 2x to save the steps. Okay, I is equal to x plus integral of okay, you see, integral of integral, need to be careful here, I spotted a mistake. So integral of integral within the brackets. Okay, so this thing is still to be integrated. So you see what is going on is x plus 1 here outside, and then we have x square plus, we take the LCM here, x square plus 4x, and then we go further integrate, and now individually, which means x cubed by 3 dot 2 x square, uh, the integration of x square is equal to x2 plus 1 by 2 plus 1. Okay, this is rough work. So, and the integration of 2x is 2 dot x square by 2. So okay, is equal to x plus 1 into x square plus 4x by 2 minus, now taking the LCM here, 6, and x cube plus 3 dot 2, which means 6x square. Okay, now we are left with the mathematics. So we open it up. X cube plus x cube plus 4x square plus x square plus 4x, yes, and by 2 minus x cube plus 6x square by 6. So we take the LCM, which is 6 in this case, and 3 times x cube plus 12x square plus 3x square plus 12x, and now you see x cube minus 6x square. So we simplify this, taking 6 as LCM at the bottom, which is already taken. 3x cube minus x cube gives us 2x cube plus 12x square minus 6x square plus 3x square gives us 9x square plus 12x. So this seems to be the form, and if we take some a factor out, which is possible in this case, I think 2 can be taken. No, not possible, because all the numbers are not the multiples. So what we do is we simply make something like this: 2x cubed by 6 plus 9x squared by 6 plus 12x by 6. So this is equal to x cubed by 3 plus 3x squared by 2 plus 2x plus c, the constant of integration. So this seems to be the very form after the integration. Yes. And now the substitution. Okay, so we have, let's say, a simple function 1 by x into natural log of x dx. So we are supposed to find the integral. So the tricky thing is the substitution. You see, natural log of x is put as equal to u, and 1 by natural log of x would be 1 by u. You see, this is because we want to satisfy the integration basics, and which is integration of 1 by x is equal to natural log of x, integration of 1 by u is equal to natural log of u. Okay, you see, so this is what we're trying to do. So you see now u is equal to natural log of x, or we just simply start off with the similar notion. It says 1 by natural log of x is equal to 1 by u, which means u is equal to natural log of x. Okay, so now the differentiation of u with respect to x would be d by dx of u is equal to d by dx of natural log of x. Okay, and this involves differentiation, which is the preliminary process which we learned before integration, because integration is antiderivative. So let me just remind that d by dx of x is equal to d by dx of a constant is equal to 0, and d by dx of x is equal to 1, and d by dx of x to the power n is equal to nx n minus 1. See, these are the things which need to be kept in mind while working with these here antiderivatives. Okay, so we rearrange. So we rather solve d by dx of u is equal to 1 by x. Now we have the solution. Okay, so now this can be put to use. Cross multiplication gives us x du and 1 dx, or simply cross multiplication gives us 1 dx x du, and now we can integrate the whole thing. Yes, so we get x here, and we get, sorry, no, that's excuse me, this is the way in the this is something we do in the differential equations, partial differential equations, or just differential equations, not the partials ones for now, but the differential equations. So we get back to integration procedures, the basics, and we try to stick to them. And which says we try and collect the like terms. We make the substitution, and we have this. You see, we have the function which is to be integrated, which is 1 by x dot 1 by natural log of x dot dx. So the substitution is, okay, wait 1 second. So du for us is 1 by x dot dx. Okay, and now we get back to the function which says 1 by x dot 1 by natural log of x dot dx. So this is the function which is to be integrated. So we change the sequence 1 by natural log of x dot 1 by x dot dx. Now we can see that we have a form where we can substitute 1 by x dx with du. So here we put du, the variable with which we're going to integrate with respect to which we're going to integrate, and 1 by natural log of x, which is here, as we assumed initially, 1 by u. Okay, so we have the situation 1 by u du. So the integration would give us natural log of u, which means natural log of x, because u is equal to natural log of x, plus c, the constant of integration. Yes, we solve now some basic cases of differentiation. Okay, so for example, we have a form which says f of x plus